Hi guys, in this video I cover pointers. Now a pointer is just a variable that stores an address. You may have heard from people that pointers are complicated or that they are difficult to work with, but they're really not. They're actually pretty simple. Like I said, a pointer is just a variable that stores an address. So think along the lines of primitive data types that you already know. For example, an integer variable stores a whole number, or a floating point variable stores a decimal number, and a pointer happens to store an address. Now, the memory of a computer is stored at consecutive memory locations. So you can think of one long line of memory, and each location of that memory has one specific address. Now in C++, an address happens to be an integer. So what pointers really store is basically an integer that represents an address. But without further talking about pointers, let's actually take a look at pointers. So the most basic pointer would be void asterisk. Asterisk is what makes it a pointer. And void means this pointer just points to basically anything. I don't further specify what it is pointing to. So it's a generic pointer, and I give this an identifier ptr. So here I have a pointer. And what can this point to? Like I said, it can point to anything. I didn't specify it further because it's void. Now let's create a variable of type integer named number and initialize it to 5. What this will do is it will allocate some memory that's large enough to store an integer, and then I assign the value 5 to it. So somewhere I have some memory location that currently stores the value 5, and I identify it by number. So whenever I refer to number in my program, this uses this memory location. Now with pointers, what I can do is I can actually get the exact address of that memory location. I will do this by assigning and then using ampersand number. The ampersand is the address of operator. So you can read this like, give me the address of the following variable. Or in this case, give me the address of number. And when I have the address, I assign it to the pointer variable. So now pointer stores the address of number. Or in other words, pointer points to number. That's where the term pointer comes from. Now what I can also do is I can output the address. So I use std cout output pointer and then do a line break. When I run this, this will give me the address of number. So here it is. This is the address. And this is sometimes where the complication comes in, where people feel this is complicated because they see these weird addresses that just don't make sense. Now this is just a hexadecimal number. You really don't need to understand this number or this address at all, because you never really deal with the address itself. You just deal with it on a logical level in your program. So here when I have this number and I see this assignment, I know the pointer here stores an address that points or that references the location, the memory location where the integer 5 is stored. And that's all I need. I don't need to know the exact address. I just need to know the address here, or the pointer points to this memory location. And when I know this, I can work with the pointer. Now, before I move on, let's clarify one thing. To actually use a pointer and make it useful, I have to know what the pointer is pointing to. Think about a real-world example. Let's say I give you some address, I give you a piece of paper and say, here's the address. You're going to ask me, what can I do with that address? I don't know what's there. So same here. If I have one pointer, you don't know what's at that address, it's really not valuable. But if I tell you, here at this address, they have really good pizza, you know if you go to that location, what's there. There's a pizza place. So here, let's change this from void to int, because this is really what it is. It's a pointer that points to an integer. And here in the declaration, you can read this. It's a pointer to an int, a pointer to an integer. Now that I have this, when I dereference the pointer, so when I do star ptr, so here the star or the asterisk is the dereference operator, or goto if you will. It goes to the memory location that of the address stored in the pointer. And when I go to this memory location, what will you find there? You will find the value 5 because it's a memory location of number. So I know when I go to that address, this is where I'm at. So when I assign, for example, 7 to it, this value will no longer hold 5. It will now store 7. And here in the output, if I change it to number and I run my program, you will see it has now 7. That is because initially I had number. Now I didn't really use number beyond that. I just got the address from it and then I outputted it. But I did use the pointer and then I went to the memory location here with the dereference operator and ptr. And then at that memory location, I assigned the integer 7 to it. And that's why number now stores the value 7. Now, let's see what else we can do with it. We can also read or use a pointer to read the data at a memory location. For example, if I have number 2, and now I want to assign the value, the integer value that this pointer points to, I can also go to the memory location that ptr is pointing to. Now when I go there, I know there's an integer, there's 7, and it reads the value, the integer value, and assigns it to number 2. So if I output number 2 here, and I run this, both of these will store 7. Now if I, for example, update number minus minus, I decrement it by 1. This value, number 2, variable number 2, still stores 7, and number stores 6. Because here I allocated a new memory location, right? Number 2, that stores 7. So if I now operate on number, it operates on the memory location up here. Now, the pointer, I can also point to something else. I can use ptr and say, I no longer want to point to number here, up here. Now I want this pointer to point to this variable. How do I do this? I do it again by using the address of operator and say, give me the address of number 2. So I now get the address of this value here. I assign it to pointer, and now this pointer stores the memory address of number 2. Now again, if I go to that address and now say I want to store 10 at that address, which variable updates? Number 2. So number 2 now stores 10. So there are 3 operators, if you will, or really just 2 operators. But there's the asterisk that is used to declare a pointer. And remember, a pointer always points to some data type. In this case, it points to an integer. And then the 2 operators here that we had was the address of operator. So this is to get an address of a variable. And whatever, typically you get the address to store it in an integer. And then the other operator is the dereference operator. It takes a pointer and goes to the memory location of that pointer. Now, this is all you need to know. In this case, I only used integers and an integer pointer, but you can also do this with any other data type. For example, you can use, when you have a floating point variable, and let's say I have 3.5, and I want to get the address of this variable. I would not be able to use ptr and get address of fraction. So this should give me a compile error because ptr points to an integer. So let's see when I run this. There we go. This just gave me the compile error because ptr points to an integer. So I cannot get the address of the floating point here. What I would need to do is get float star, and I call this my pointer, or let's say float pointer. And this will work because now I can store the address that points to a float. So the compiler makes sure in this case that it really points to the correct type. And then everything else is the same. So just remember that when you have a pointer, typically you define what is located at that address. So you always have a pointer that points to a float, or a pointer that points to an int, or a pointer that points to a bool. Now, you're probably wondering, why would you need this? Why would you make it overly complicated? Everything that we did here, you can just do with primitive data types. You don't really need pointers. That is correct for very basic programs. But as your programs become larger, pointers become more and more useful and important. For example, think about you have functions. And let's say you want to pass a value to a function. Typically what happens is it takes the value, for example, 5 or 7, whatever the value of a variable is, copies the value and gives it to a function. Now, when you have an array with, let's say, 1,000 of values, you do not want to copy 1,000 values in memory. It's very time consuming and very inefficient. And the more data your program deals with, the slower the program will get. So instead, what you would do is you would get the address of that array and then pass the address to the function, or pass the pointer to the function. And now the function can use a pointer to go to that memory location. It will find an array, and then it can operate on that array. So the more data structures and the larger the data structures are, and especially if you deal with classes or structs or other data types, pointers become very handy because you can just pass pointers around and you don't have to copy large amounts of data just for each function call. Now, I hope you enjoyed this video, and I hope this gives you an easy understanding of what pointers are. Thank you for watching.